Good morning, children. Let us start today's class. In the previous day, what we have learned, you all of you know. I hope you all practiced well in the rough notes, I think. So today also you have to take your rough notes and pencils for diagrams and get ready for the class. Listen the class well. If you have any doubts, later you can ask the doubts to me. Okay. In the previous class, what we have learned? We have learned about the electric potential. Am I correct? What is electric potential? Electric potential at a point P is equal to the work done by an external force to bring the unit positive charge at a constant velocity from infinity to that point in the external electric field. Okay, that is electric potential. Am I correct? This electric potential have the SI unit. The SI unit of electric potential is joule per coulomb. We have learned in the last class. Okay. Today, I am going to teach electric potential due to a point charge. Okay. Electric potential due to a point charge. Because of the point charge, what kind of electric potential we are experiencing at a particular point. Okay. So for this, we have to consider a unit positive charge. We have to keep a unit positive charge at a particular point plus Q. Okay. So from this point, we have kept at a origin. Okay, at an origin. So, we have to take a particular point P. Okay, that point P is at a distance R from that plus Q. Okay, so R from the plus Q, the distance of P is R. R is the distance. In the last class, we have learned the potential difference, electric potential. Electric potential V is equal to integral P infinity to P then minus E dot dr. E is the vector quantity, this displacement. This is also a vector quantity. Okay, so V is equal to integral infinity to P minus E vector dot dr. This we have learned. So today, at a distance R, the distance we are going to mention here from infinity to a distance R, how much work done we are going to that external force, applied external force is going to do. What is the work done? That work done only electric potential. Okay, so V is equal to integral the electric potential at a point P due to this point charge plus Q. This plus Q, because of this plus Q point charge, this P experiencing some electric potential. So what is that electric potential? That electric potential V is equal to integral infinity to R minus E vector dot dr vector. Okay, this is electric potential. Next, electric field we have to know. So here this electric field E. So what is the electric field? Because of this plus Q, this P is experiencing. Okay, due to this plus Q. So E is equal to, E vector is equal to 1 by 4 pi epsilon 0 Q divided by R square R cap. This is the electric field at point P. Okay, electric electric field at electric potential at point P. This is electric field. So this one is equation number 1. This is equation number 2. This equation number 2 we have to substitute in equation number 1. Okay. So V is equal to electric potential V is equal to integral R infinity to R. In this minus E place we have to substitute here 1 by 4 pi epsilon 0 Q divided by R square R cap dot dr vector. Okay, dr vector. Now we know this R cap, this is unit vector. So dr vector, this dr vector is R cap dot R cap dr. Okay, R cap dr. This is the value. This is infinitesimal decimal vector. Okay, so infinitesimal displacement vector. Sorry, infinitesimal displacement vector. This is dr vector. So R cap. So this we have to substitute here in this equation number. We can take this equation number 3. So V is equal to integral infinity to R 1 by 4 pi epsilon 0. This 1 by 4 pi epsilon 0 we can take outside. This Q also we can take outside. Otherwise first we can take 4 pi epsilon 1 by 4 pi epsilon 0 outside. Q divided by R square R cap dot. We have to substitute this R cap dr instead of this dr vector. So R cap dr. Okay. Now this we know R cap unit vectors. The dot product of two unit vectors are 1. Okay. So this we have to substitute here. While substituting, what do we get? V is equal to this Q also we can take outside in this step. So 4 Q divided by 4 pi epsilon 0 integral R infinity to R. So R dot R cap dot R cap 1. So we can eliminate that. 1 into dr, 1 over dr. So we can eliminate that. So dr by R square. Okay. So now we can integrate. How can we integrate? Q divided by 4 pi epsilon 0. So this R square we can bring to numerator. So this one will come as R power minus 2. Then integrating time plus 1 divided by minus 1. Then R infinity to R. Okay. So Q divided by 4 pi epsilon 0. Here also minus 2 plus 1. So it will become minus 1. Okay. So this minus will come. Here R power minus 2 plus 1. R power minus 1. So minus, this minus will come here. So minus 1 by R. Okay. R to infinity to R. So Q divided by 4 pi epsilon 0. We have to substitute this. So minus 1 by R minus 1 by infinity. 1 by infinity will become 0. So this term neglected. So equal to Q divided by, here V, the potential difference, electric potential V is equal to Q divided by 4 pi epsilon 0 into minus 1 by R. So we can write minus 1 by 4 pi epsilon 0 into Q divided by R. Okay. This is the expression for electric potential. This is a V is equal to, this is the expression for electric potential, minus 1 by 4 pi, no, infinity, sorry, here R, then here infinity, here, so minus we cancel, minus 1 by R. Okay. So this minus, here minus of minus 1 by infinity. So here it will become plus. Okay, how it is coming infinity? First we have to do this. So 1 minus of minus 1 by r. Here minus of minus 1 by infinity, minus of minus will come. That time this minus and this minus will come plus. So here minus. So v plus. So v is equal to 1 by 4 pi epsilon 0 q divided by r. This is the expression for the electric potential. Okay. So here one more thing you see, sorry, here one, here this is correct only. This term is correct only here. This minus. Okay, this minus here. Minus will come. All the steps we have left the minus. So minus, minus, minus. Here minus. So minus 1 by r. R infinity to r. So here also minus. This minus and minus into minus plus. Like that, this minus will cancel. So v is equal to 1 by 4 pi epsilon 0 q by r is the final answer for the electric potential. Okay, here some important points are there. Okay, if the source charge is here, this is the source charge. If the source charge is positive, electric potential also positive. If the source charge is negative, the potential also negative. Here minus will come. If the source charge is negative, here minus will come. Okay, but the source charge is positive, so answer is also positive. Okay, the second point, the description of motion of objects, we want to learn in the terms of electric potential only. It is simpler. Okay, electric potential, if you are learning this description of motion of objects in electric potential, it is simpler than the concept of electric field. Okay, it is easier. Then third point, the potential of the positive charge decreases when the distance is increasing. If the distance is increasing, the potential of positive charge at point P decreasing. Okay, the potential due to negative charge at P increases if the distance is increasing. Okay, next, if we want to find out the collection of charge, here one single charge only we have taken. If the point P is surrounded by a lot of charges, many charges, we have to find out the vector sum of collection of charges, electric potential of collection of charges. Okay, that is the last one. The collection of, we have to find out the vector sum of the electric potential of individual charges. That only if we have the number of charges around it. Okay, now here we are finding for one charge. Okay, all of you understood this derivation, I think. Electric potential. So electric potential value formula expression V is equal to integral infinity to r minus E vector dot dr vector. So electric field at point P. So this formula we know. This formula we have to substitute there. Okay, that formula substituting in the first equation. This equation we are getting the third equation. So the third equation dr vector is equal to r cap dr. So in the place of dr vector we have to substitute this r cap dr vector, r cap dot r cap 1. So r cap dot r cap 1. So in this here we are getting dr by r square. Here we have to integrate. Integrating time we are getting minus 1 by r. Okay, minus into minus plus. So we are getting V is equal to 1 by 4 pi epsilon 0 q divided by r. Okay, this is the expression. And if you understood, I think you have written in the blackboard, in the notes, rough notes, I think. So practice well. This is an important question. Explain the electric potential due to a point charge. Okay, so you have to know thoroughly. Next, electric potential. I am not going to rub it. First I have explained electric potential due to point charge. Now I am going to explain electric potential due to electric dipole. Okay, electric potential due to electric dipole. This is an important 5-mark question. Okay. First, we have to draw the diagram. What diagram we are going to draw? We have to consider an electric dipole. In the previous classes we have learned what is electric dipole. Equal and opposite charges separated by a small distance constitute an electric dipole. Okay. So here we have taken here minus q, one charge, plus q, another charge. Okay. Is separated by, this is the origin, this is the center midpoint of these two charges. So here the distance a from O to minus q, O to plus q, a is the distance. Okay. We have located a point P at a distance or from the midpoint O. From the midpoint O, we have located a point P. Okay. Now, this point P is at a distance R1 from plus Q. This point P is at a distance R2 from point minus Q. Okay, from minus Q. So, the line joining the midpoint and the particular point P, that is OP. That OP making an angle. Here, before that, you see this minus Q, we can write your name A, here B. Okay. So, this OP making an angle AOB line with AOB line theta. Okay, this angle is theta. So BOP angle, that is theta. So remaining totally, this total angle we can take as 180. 180 minus theta only remaining. So 180 minus theta. Totally 180. That 180 you have to subtract this theta. So that is the remaining. So 180 minus theta. Okay. Now, what is the potential? This plus Q, because of this plus Q charge, this P is experiencing. Because of this minus Q, how much potential this P point is experiencing? Okay. First, we can calculate the charge. The electric potential experienced by this point P due to plus Q charge. So, you can write here the electric potential due to charge plus Q at point P. Okay. We know the formula for electric potential 1 by 4 pi epsilon 0 Q divided by R. This is 1 by 4 pi epsilon 0 Q divided by R. But R, what is the distance between it? R1. So that R1 we have to write here. Next, electric potential due to charge minus 2 at point P. At point P is equal to, this is minus charge, minus 2. So, negative charge have the value negative. Okay. So, minus by 4 pi epsilon 0 q divided by r. Minus 1 by 4 pi epsilon 0 q divided by r. What is r here? From the distance from minus 2 to p. R2. Okay. So now these two separately, now total potential we have to find out. Total potential. Total potential at point P because of this electric dipole. These two equal charges separated by a small distance, equal and opposite charges separated by a small distance, this constitutes an electric dipole. So because of this electric dipole, what is the total potential? Okay, total potential at point P is equal to 1 by 4 pi epsilon 0. Both we have to add. Epsilon 0 q divided by r1 minus 1 by 4 pi epsilon 0 q divided by r2. Here, which are the common terms that we have to take outside? We will taking outside 1 by this q and 4 pi epsilon 0 common. So q divided by 4 pi epsilon 0, then 1 by r1 remaining. If we are taking q divided by 4 pi epsilon 0 outside, what is the remaining there? 1 by r1 minus here q we have taken outside, 4 pi epsilon 0 taken outside commonly. So 1 by r2 is there. Okay, 1 by r1 and 1 by r2. Here is that okay, this is electric potential V, total potential. And if you understood this much, now we can apply the cosine law here. Okay, for we have to find out R1 value and R2 value. We can find out this R1 value and R2 value. While finding this R1 value and R2 value, we can use cosine law. Okay, cosine law for this BOP. For BOP. If you are finding the cosine law for BOP, what do you get? R1 square is equal to R square plus A square minus R square plus A square minus 2RA cos theta. This is theta. Now, we can find out R square we can take outside. R square into this R square we want to take outside. So 1 plus A square by R square minus 2RA cos theta by R square. Okay. So here R cancel. Here A square by R square we have to neglect. Because if R is very greater than A, we want to neglect this. So R1 square minus equal to R square into 1. This we can neglect. So 1 minus 2A cos theta by R. 2A cos theta by R. Now we have to find out the reciprocal for this. Reciprocal finding take 1 by R1 square. No, R1 want to find it. R1 is equal to R into 1 minus 2A cos theta by R. The whole power 1 by 2. What is 1 by 2? The square root of R1 square is R1, R square is R. 1 minus 2A cos theta by R. For that, if you are finding this, finding the square root, we can write the whole power 1 by 2. Okay. Now we can write this in reciprocal. 1 by R1 equal to R into 1 minus 2A cos theta divided by R, the whole power 1 by 2. Because this whole term, when going the new denominator, it will become here minus. Okay. It will it will go denominator. Then if you are bringing up, it will become as minus 1 by 2. Okay. Now I am copying here. You have all written this. I am thinking, but this equation we can. Okay. Now R1 we have found out. Now we want to find out R2. 1 by R2. So finding 1 by R2, this AOP. Okay. Cosine law for AOP. Now before that, children, this term we have to write in this value A by R. A by R is very lesser than 1. So we have to find out, we have to use the binomial theorem here. While applying binomial theorem, this term will change as 1 by R1 equal to R into 1 plus A cos theta by R. Okay. This term becomes 1 plus A cos theta by R. This is the binomial. After we are applying the binomial theorem, we will get this. This is the final. This is not the final. This is the final. Okay. Now 1 by R1 found out. Same way we have to find out AOP from cosine law. Okay. So cosine law for AOP. Okay. So AOP finding time R2 square. R2 square is equal to R square plus A square minus 2RA cos theta. Theta is 180 minus theta. Okay. So 180 minus theta. So R2 square is equal to R square plus A square. And now before this, one thing we have to see, cos 180 minus theta is equal to minus cos theta. So we have to substitute here minus cos theta. So R2 square is equal to R square plus A square minus 2RA minus cos theta. Okay. This minus cos theta, this minus and this minus will become as plus. So this cos theta 2RA cos theta plus 2RA cos theta. Same way we have to find out. So A square by, if R is very greater than A, we have to neglect this term. We neglected, same way we want to neglect. Then R2 square is equal to R square, no, R square 1 plus 2RA cos theta by R square we will get. Okay, R cancel. So we will get R 2A cos theta. Here also we have to use binomial. Okay, binomial theorem here. While using binomial theorem, same way we have to do. Same thing only. Here what we have done. That same thing only we have to do. What is that? So R2 square. R2 square. We have to find out R2. So R2 is equal to R into 1 plus, here there minus, here plus 2A cos theta by R, the whole power 1 by 2. Okay. So 1 by R2 is equal to R. What will you get? 1 by R. 1 by R into 1 minus 1 plus 2A cos theta divided by R, the whole power minus 1 by 2. How this minus 1 by 2 coming? All the terms we are finding reciprocal. Okay, R2 reciprocal 1 by R2, this one. This reciprocal minus 1 by 2, R power minus 1 by 2. Okay, so then we have to use binomial theorem. Binomial theorem using time for the first order we have to find out. So 1 by R2 is equal to 1 by R into 1 plus, here minus. Okay. Here plus came. So here minus A cos theta by R. Okay. 1 by A cos theta by R. Understood all of you? So we found out 1 by R1 and 1 by R2. Okay. This one we have to substitute in the first equation. What is that equation? I am rubbing everything. What is the first equation? B is equal to 1 by 4 pi q divided by 1 by q divided by 4 pi epsilon 0 q divided by 4 pi epsilon 0 1 by r1 minus 1 by r2. Okay, so 1 by r1 minus 1 by r2. So B is equal to q divided by 4 pi epsilon 0. Yes, sorry, here 1 by r1 will come. 1 by r, not r1. Here 1 by r1. Okay, so B is equal to q divided by 4 pi epsilon 0. What is 1 by r1? 1 by r into this value not here I am, and after binomial we got 1 by r1 equal to 1 by r into 1 plus a by r cos theta we got. Okay, I am writing here 1 by r1 equal to 1 by r into 1 my plus a. After binomial theorem, after including binomial theorem we got this a by r cos theta we got. Okay, that we have to substitute here 1 plus a by r cos theta, then minus what is that next one? Okay, 1 by r2, 1 by r into 1 plus 1 plus not minus 1 minus a by r cos theta. Okay, this only we got. We have to solve this. Q divided by 4 pi epsilon 0. Here 1 by r is common in the both the terms. So 1 by r we can take outside. So 1 by r remaining 1 plus a by r cos theta. Okay, then this minus will go inside. So minus into plus, minus 1 minus into minus plus a by r cos theta. Okay, so plus 1 minus 1 cancel. So q divided by 4 pi epsilon 0 1 by r. Here a by r cos theta plus a by r. So 2a cos theta divided by r. So r into r square. So q divided 2a cos theta is divided by 4 pi epsilon 0 r square. Okay, we know already P vector, electric dipole moment. P vector is equal to 2qa. Okay, so instead of this we can write, okay, so total potential, so equal so 1 by 4 pi epsilon 0. 2qa means P vector cos theta. Cos theta, P cos theta divided by r square. Okay, what is P cos theta? P cos theta is equal to P vector dot r cap. Okay, so this is the total electric potential due to this point P experiencing because of this electric dipole. Okay, because of this electric dipole, this P is experiencing an electric potential. That is V is equal to 1 by 4 pi epsilon 0. So P cos theta by r square. So P cos theta value we can substitute. V is equal to 1 by 4 pi epsilon 0 P vector dot r cap divided by r square. Okay, this is the value. So here some cases are there. Sometimes the point P, if the point P is lying this side, the side of this plus what will happen? What will happen to this angle? So the angle is theta. Angle theta is equal to 0. The first case, if this point P is the axial line near to in the side of plus q, what will happen? The theta will be 0. So if the theta is 0, cos 0, 1. So the value will come 1 by 4 pi epsilon 0 p by r square. So cos theta 0. Theta is 0. Case 1. In the case 1, cos theta, theta is 0. P cos theta, cos 0 will come 1. So the potential is equal to 1 by 4 pi epsilon 0 P divided by r square. Okay. At the same time, the point P is in the side. If that point is in this side near to minus q, the same axial line, the angle theta case 2, the angle theta is 180 degree. The angle theta is 180 degree, cos 180 is equal to minus 1. So the answer we will get 1 here cos theta 180 degree. So we have to substitute here cos theta 180 degree. So minus 1. And so coming to 1 by 4 pi epsilon 0 minus p by r. So that minus we have to write here. So minus 1 by 4 pi epsilon 0 p by r square. Okay. This is the value when the point P is near in the axial line in the side of minus q charge, negative charge. Okay. If that point is in the equatorial line. If the point P is in the equatorial line, what will happen? If the point P is in the equatorial line, case 3, theta is equal to 90 degree. So if theta is 90 degree, cos 90 is equal to 0. If cos 90 is equal to 0, what will happen? Totally, all the terms here, 0, 0 by r square 0, everything 0. So, V is equal to 0. Electric potential is 0. Okay, these are the 3 cases. So, this question is important. Electric potential at a point due to electric dipole. Today, 2 questions we have learned. First question, electric potential due to a point charge. Okay, so this one second, the electric field, electric potential due to electric dipole. Okay, what is electric dipole? Two equal and opposite charges separated by a small distance constitute electric dipole. Okay, these two charges are same values but negative charge totally opposite. So at a point P, what this point P is experiencing, how much, what type of electric potential, how much electric potential it is experiencing. Because of this electric dipole we have learned. Okay, so this is very important one. So you have to write this and learn well. So if you have any doubt, you can ask to me. Okay, if you have any doubt, you ask to me. In this manner, you have to learn. Okay, important points are here. What are the important cases? 3 cases we have learned. What are the cases? If theta is 0, cos 0, 1, so the potential will become P by r square. So case 2, when theta equal to 180. Case 2 that. In the case 1, that point P is in the axial line near to in the side of plus q. In the second case, that point P is in the axial line near the side of minus q. In the axial line. In the third case, the point P is in the equatorial line. If it is in the point P is in the equatorial line, theta is 90 degree. So totally there is no electric potential. Okay, there are three cases. So what are the cases that decrease? The distance increases from the electric dipole, the effects of positive and negative charges nullify. Okay, effect of positive and negative charges nullify. So the potential due to point charge is spherically symmetric. Spherically symmetric. What is that? Symmetric. The point charges, the electric potential to point charge is totally spherically symmetric. But the potential due to dipole, because in dipole two charges are there. This is not symmetric. Okay, spherically symmetric. So in the first case, we have learned the potential due to point charge is spherically symmetric, but potential due to the dipole is not spherically symmetric. Okay, these are the two important points. So you have to learn well. So in the next class we can continue this. So whatever here given, the derivation you have to take a note and write and see several times. If you write and see, you can practice well. So it is easy for you. So whatever this much classes we have taken, I have taken, all you want to know well. So everything you learn. Whatever have doubt, you can contact me and ask well. Okay. So thank you children. Thank you.